So I'm Elaine van Bergen, and I'm here to talk to you a little bit about serverless in Azure. If you want to get a hold of me afterwards, if you have any questions after the conference is finished, the best way to grab a hold of me is via Twitter, where I'm at LaneyVB. So before we dive into some of the technical demonstrations, I thought we'd talk a little bit around what is serverless, just to give you a little bit of an overview of why these technologies are important. So with serverless, one of the key things that we're looking at is that there's no software or servers to manage anymore. It really is as simple as you just deploy your code and it's going to run for you. Simple and easy, no need to manage servers, nothing to patch, no administration tasks necessary. So that's what we're referring to as abstraction of servers. One of the other fundamental tenets of serverless computing is event-driven capabilities. So we're only firing our code here when an actual event triggers it. It's not running all the time, it's just waiting for the event to be triggered. And then based on the number of events, we automatically scale without any need to pre-organize compute power to be able to do that. And that scaling can be anything from 0, when you've got no events firing, to tens of thousands of simultaneous events running at one period of time. That's what we're calling event-driven instant scale. Now, finally, we have micro-billing. It's very important that the way that we charge matches that event-driven process. So with micro-billing, you're only being charged when those event executions are actually occurring. If you've got 0 events firing, you're not being charged. When you do have events firing, you're actually being charged for the resources and the number of executions that are occurring during that time period. So it can be a really, really cost-efficient model for those particular pieces of code. Also, it's very quick and easy to get set up and use, so it's really, really nice and easy to jump into. And I'll show some of the methods for doing that a little bit later. So let's talk about what serverless is on the actual Azure platform. In the center of the Azure platform for serverless computing, we have 2 main pieces. One of these is functions, and we'll spend a bit of time on each of these further in the session. You'll even see some demos so you get more of an idea. But with functions, we're really looking at that event-triggered piece of code that's nice and simple, light, connecting through to different systems, and it actually runs on an open source framework. So what that means is that framework that runs these functions, you can pick that up and I'll show you how it runs on your development machine, but you can also run it on servers as well. So it gives you a really flexible model that you can use both in Azure, but also on premises if you need to. Then we also have Logic Apps. This is that workflow capability. So we're using a visual designer to provide some logic around how those events are ordered and how they run, whether that's with Azure Functions or with any number of the additional connectors that we have. In fact, there's 125 plus connectors at this point in time. So it's providing those capabilities to control the flow and logic in between what we're trying to do. Now, they're the 2 main pieces of the serverless platform, but of course, they interact with all the normal pieces of Azure that you've been hearing a lot about throughout this conference. So we have our data and storage layers and our messaging layers. These can be used both to trigger the functions and logic apps, but also as bindings so that we can send things to these queues or file storage or database tiers as and when we need, with both our functions and logic apps as well. In addition to those native Azure-based connectors, then we also have gateway connectors for a number of SaaS and cloud and hybrid systems as well across the board. One of the other common pieces with the Azure platform is we also often tie in pieces of intelligence. And you've already seen quite a few demos of things like those cognitive services. And you can utilize those same services within your functions and within your logic apps to provide additional intelligence. You can also add in Azure Machine Learning for that additional level as well when and if you need it. And then finally, we have bots. Bots are actually a serverless way to show a user interface on top of this Azure platform. So you're providing interaction with consumers, typically only when when a message is actually being sent to them. So it's a simple example of a serverless option. Finally, of course, to be able to develop all these great things and get using Logic Apps and Azure Functions, there's a range of support that's offered, right through from the IDE support that you're used to, and we'll actually show you some of the IDE support in Visual Studio at the current point in time, as well as the ability to debug, see what's happening, trace what happened and where it went wrong, and also perform that development locally so that you don't need to be always connected to do all these bits and pieces. So now that we've talked about a high-level overview of what the capabilities are, let's deep dive into a couple of these things a little bit further. Firstly, we're going to spend some time talking about Azure Functions. Azure Functions are really where we're combining code with events, and it's that simple. So, you know, whenever you think about Azure Functions, I want you to think about event-triggered code here. With our Azure Functions, we have what are called triggers, and they can be a number of different activities. So very common that you'll put things onto a queue and trigger off an action, or put items into blob storage, for example, and trigger off your function, or via an HTTP request or a webhook. In addition to the triggers for how we kick off our Azure function, we then have our bindings, which are a range of other systems that you can then talk to from the function. The great thing about the triggers and the bindings, which I'll show in the demos, is you don't have to code up yourself those connections. There's no, kind of CRUD code that we're developing. It's all quite declarative and very easy to build these functions. Now, some of the things that we also want to address is, why would you do this though? Why are we separating out these Azure functions from the rest of your code? A really good reason for that is to provide additional scalability. Remember I said at the start, these scale up based on what's happening. So, if you've got no things that are triggering this particular activity, you're not going to be charged for that particular function sitting there and long running. So by segmenting it off, you're providing this separate scale point that can go up and down based on different pieces of load, as compared to something like a website or an API layer that may be running all the time. In addition to additional scalability, it also gives you more flexibility and the ability to update that code without interacting and causing problems with the other bits and pieces. So for example, if you're using this for back-end processing tasks, you can have a separate development and deployment lifecycle that will actually give you the capability to update the function without touching the main pieces of code. And it's very common that when people are looking at trying to break out from really large monolithic applications, introducing these pieces of Azure Functions can help provide that flexibility. It also makes it quick and easy as well to get started and also break off those pieces. And because we've got the functions separate, it makes it very, very easy for lots of different business systems to call them as well. So now we've talked a little bit about the why you might want to use Azure Functions. Let's dive in and have a look at some. And we'll start with some slides, but then don't worry, we're going to go into a live demo in a minute to actually show some of this stuff working. So here's an example of an Azure function created in the portal utilising JavaScript. And you can see some of the main elements have been highlighted here. So at the top, we have the red boxes around things, which is actually our trigger. And in this particular case, our trigger is actually a queue. And you can see that that queue is what's triggering the function, but then we're also using it in a few places throughout the code down below. And then we have one single output binding, which in this case is a blob. And we're then using that, we're actually writing out to that towards the end of the function. How we configure the connections for that is in the binding file, which you can see off towards the side. So we've completely separated, those two concepts. Where in our code, we're just declaring really what are the pieces we want to interact with, and then we're using settings to control where it's talking to. And obviously a big advantage of that is that it means when you're running on your local development machine, you might want to run off different settings as opposed to when you go through the deployment life cycle. And you could change out these variables as things get published to test and production without having to recompile and change the main pieces of code. So with this example in JavaScript, this is one that was created, as I mentioned, through that Azure portal. And we actually support creating both JavaScript and C# functions through there. as well as the ability to create custom functions through other technologies, including PowerShell and Batch. There's also a wide range of other pieces that you can use as well by creating that custom function piece rather than just the online tooling. But recently, we've also launched the new Visual Studio tooling for Azure Functions. And this looks a little bit different. So this is a C# example here of a Azure Function class that's actually happening. You see it's quite similar in syntax. It's got lots of the same elements, but just a little bit of a different layout. So basically in C#, we're actually using attributes for each of the pieces so that we know what we want to do. So the first attribute you can see at the top is function name. That's where we're declaring which bit of our code is actually the function. You might have this in a class library with a lot of different methods, and it's really that simple of saying this one's the function and this is, indicating that that's where the code's going to be called from. Then we have our queue trigger highlighted in blue there. That's what's kicking off the function. And in this case, we are using a queue for that. And you can see we've used some syntax there to say it's actually a variable, and we're going to pull that in from our settings file. And then we have a little bit different in this case in that we've got two actual bindings. So we're not just limited to an input and output binding. We can actually have multiple of these that we use in different scenarios. So here we've got both a blob storage and we've got the document DB binding that's actually over in that settings file with our connection string that we need to connect on through. And then it's actually using some variables here. This is quite an interesting scenario because you'll notice that in the blob binding, we're using this the kind of bracketed blob name. It's actually pulling that variable from the queue item that is passed in. So we're actually pulling it out of our input trigger and then using that to pick the right matching blob up from the item as we go. And we didn't write any of that code, right? Like all this connecting, pulling data, getting an item off a queue, writing back to a document DB, we don't have to write any of those bits and pieces. All we're doing is concentrating on the middle piece and worrying about the business logic and the code required to be able to solve the problem at hand, rather than all that plumbing code that we spend a lot of our time writing in other kind of models. So really, really efficient and easy to do and quick to get into as well. We're going to jump into a demo in a second, but before we do the demo, I thought I'd just talk a little bit about the architecture so you have a bit of an understanding as to what we're doing. Now, I'm a strong believer that you can't have too many cats on the internet, so we're actually going to use a cat review site as an example here. And the way users interact with this is they're going to grab a picture of their favourite cat, upload it into our website, and provide some text on top of that. So that's the architecture you can see here. The Azure website is what the user is actually hitting, and then those particular artifacts are written across to 3 different places. The file itself, which is containing the cat image, will go into blob storage, and then we're going to store the metadata for that review item in the document DB behind the scenes. Finally, we need to trigger something. So we need something to link together and say, where's that storage item and where's that document DB, and link it all together and kick off our function. And that's what the entry on the storage queue does. So as soon as it sees the new item popped onto the queue, that's going to actually trigger our function, which you'll see here. The Azure function will then go off and it will pick up those items using bindings that we added from the website. So it's going to go off to blob storage, pick up the file, and then it's going to go to the document DB and actually grab that record out that matches as well. And what we're going to do with those bits and pieces is we're actually going to fire it off to a couple of the APIs for cognitive services. And so what we want to do with those pieces is we want to send the cat image across to our computer vision APIs because we want to make sure that it's really a cat. So we need to double check, of course, that we're not going to upload any different malicious software to that. And we also want to make sure that with the content moderator text, we're actually not going to upload any, dodgy text. And, you know, we're all Australians. We like to put in a bit of fun imagery and image titles. And that's what we're actually going to double check with this content moderator and computer vision calls. Once it's come back, we're then going to write the results of both of those APIs through actually back to our document DB, and that's what will be displayed on the website. All right, so let's flick across and have a look at our demo architecture. Okay, so here on my demo machine, I'm actually running the preview version of Visual Studio 2017. This is necessary because the Azure Functions tooling is actually only in preview at the moment. But it's really good because I can actually install it side by side with my main Visual Studio installation. So I've got that Visual Studio 2017 base installation, and then I've also got the preview installation to the side. And then I've added the Azure Functions tooling on top of that. And this gives me the capability to create a new Azure Function project through File, New Project, and then you'll see that I have the option there under Cloud for Azure Functions. Just like any kind of environment, that will just give me a new project with the necessary files in it that I need. You can see it's a pretty basic project structure. Once I've got my project created, then I add a new item, and this is where I actually pick Azure Function from my selection. And once I've picked Azure Function, I now have a bunch of those different queue types and trigger types that I mentioned that I can select between. And you can see as I go through these different options, it's going to give me different settings based on which particular one that I pick. So for example, if I select here my timer trigger, you can see I've got a cron expression that I can use for how often I want that timer to actually fire the function. So, you know, by default, it's going to fire it every 5 minutes. Whereas if I pick something different, like a queue trigger, it's going to ask me what my connection string is for the queue and what is the actual name of the queue that I want to hook it up to so that I can pick those pieces. And so getting started with an Azure function is really that simple, and that will then give you all the setup that you need to actually start writing your code. But in true demo style, we're going to look at one that I prepared earlier. So here's that Azure function. You actually saw very similar to this demoed on the slide. So you can see I've got a whole bunch of code here in the same class file, and then I'm specifying the function I want to call, again with that attribute. So it's actually demonstrating that this method here is a particular function to call. We have our queue trigger, and we have our two bindings. So I'm actually picking up both the ID of the document record and the blob name from the queue item, writing it in, and then I'm going to do some things with it in between. To get that all connected, I have my local settings file, and this is the most important thing that you need to fill in at the start. For all Azure functions, you need to tick up this Azure Web Job storage and actually connect it up to a storage account. Otherwise, the majority of those triggers will not work when you're trying to fire them locally, with the exception of the timer-based one, because that doesn't really need a connection to do anything. And in here, you can put as many other settings as you need throughout your bits and pieces. All right, so we've got our code here, and you can see it's pretty simple at this point in time. What we're actually doing is we're assuming that people are always uploading a cat, and we're actually sending it through to our content moderator text. But I want to make that a little bit more complicated, as we mentioned earlier. So I'm just going to replace this section here with actually calling our image moderator to check that it's a cat, and then combining the results. So it's only approved if it both contains a cat, but also passes our text moderation piece. And then I'm passing that result back here as a caption item into the document database. And finally, I'm going to omit some custom telemetry, which I'll show you in one of those dashboards that was mentioned in the keynote, where you can actually have these reporting dashboards coming back. Now, one thing you may or may not have noticed is that as I change that code, I've got some green ticks going on down here. And that's because I'm using the enterprise version of Visual Studio with live unit testing turned on. And I've actually got this unit testing project down below defining the tests. So the really interesting thing about this is it's firing those unit tests as I'm changing my code and not needing to wait for me to compile. Luckily, in my case, it looks like I've got all green ticks and I don't have any errors, so the code is going to run. But imagine in complex scenarios where there might be quite a big deployment process to test your code, how much time that could save you just through this inline checking of what's going on within the code as you fire it. Also, just to prove that it's just the same as any other kind of artifact within Visual Studio, you'll see on the items that we use, like for example queue input, we have the normal expected IntelliSense. So there's not really anything fancy you need to know to be able to write the code in between. All right, so we've got our Azure function updated the way we want. So let's give that a go at running it. And we're running here just on a Surface 3 laptop device, nothing special, just the tooling got this up and running, and you can see that it's kicking off that Azure function, and it's actually jumped into my breakpoint, so we'll just push that through, and then we will go to our website. All right, so we're going to add a picture of a cat. This is actually my sister's cat. She doesn't really like it when I call it that, but, sister rivalry. I've created the review in there, and we should actually now see, if the demo gods are lucky, this will actually kick off the item when it picks up that's gone through to the queue. So we'll just give it a second while that kicks in. And there we go. So this is great. I can debug now. Just, I've actually had that trigger of putting something in a real Azure storage queue, but I'm running on my local machine. And I'm going to step through the code and we'll be able to see all the items that are happening and those interactions that are happening with the cloud right from here locally. So let's step through these calls. Let's double check what results we're getting. So, yep, I didn't put any swear words in there. We passed the test. We've done well with that. But luckily it's picked up. It's not actually a cat. My sister was right for once. Don't tell her, she's not here. And then we're going to update through, send our custom telemetry in, and you'll see as we do the next step that it actually finishes out through the function. Really small amounts of code for connecting and doing those bits and pieces. And then let's do the final check here. Okay, great. And you can see that it's actually pulled back the text. So our cognitive services picked up that it was a dog and it rejected everything for us. Really nice way. Now remember, we've separated these pieces because it gives us, A, the ability to change and update them independently. So if a user's interacting with the website and uploading these pictures, they're not waiting for the result to, the results of the call to happen synchronously. It's an asynchronous process behind the scenes to do what could be heavy lifting of talking through to a couple of business systems, getting this review item to happen, and then it's publishing the result out when we needed it. So now that we've got our code updated, let's talk a little bit about how we might deploy that. So one of the ways that we can deploy it from off my local machine up into Azure is through using the inbuilt publish settings of Visual Studio. So I could just hit publish here, and it's going to then go, in this case, create a new Azure Function app, or I could select an existing Azure Function app that's already published and push it through the chain that way. That's really good for when you're developing, right? And you might not have anyone else interacting with this stuff. But it's not a very robust process if you need to go through to production. So for those scenarios, we can actually use Visual Studio Online to create a build pipeline. So we're just going to check in our code, and we'll just commit that up to our repository, and then we'll sync it, and we'll push it. And what this is actually going to do is I've got a build pipeline sitting up in Visual Studio, and as soon as it detects a new check-in, it's going to have a whole bunch of activities that actually kick off in the back end to control what's happening with that. And we can actually see here, so I've been pretty good coder through my demos. We've had all green ticks, so fingers crossed this one we get a green tick for as well. But at the moment, it's in progress. So if we just kick that off, this will actually show us what's happening. And you can see here my build has automatically happened on that commit of the code and the push up to my repository. What it's actually doing right now is it's testing. It's running those unit tests up in the cloud for me to make sure before it performs those next steps of actually pushing the activities, it will only do that if my unit tests pass. And this is a really simple build pipeline that we're using here, but you can make this a lot more complex for your own scenarios. So you could have manual steps where you might want to seek approval from a manager before it goes through to production. Maybe you want to perform a load test in between there to make sure that the code's going to actually stand up to production load. Just like with any service, we can add those pieces in. All right, so while that's finished, and you can see here then we've got our dashboard that actually just reports on a lot of those bits and pieces. But the other dashboard we also have is application insights, and you would have seen these a few times already through here. So we've got our normal timelines here we can see of when people are hitting the website, and we can also see our flow through and which pieces of the code are running slower than others. But we've also got this custom visualization here. Well, it's not a custom visualization, it's a query on the information that we've pushed through to application insights. And what this is actually reporting on is how many images we've had of the different types. So we've had the majority of them have failed because I've been uploading a lot of dogs. But we've had some that have actually passed and gone through. And this means that along with our reporting, we can actually do this via our code and submit custom pieces of data and have it displayed on the same application insights dashboards. Behind the scenes, we even get a lot more advanced information. So as I click on through to this, it will actually authenticate me, and then it's going to show me the SQL-like query that I'm actually using to create that visualization on the dashboard in between there. And so what that means is that if I then needed to go and grab more detailed information on what's happening, I can dig right into this application insights piece and get those pieces out. All right, so let's switch back. That way. Okay, so what you've seen there is both the inner loop of exactly how easy it is to get an Azure function up and running and locally debug it. Really super easy, and I couldn't imagine doing even half of those tasks when I started my career in IT. Debugging off my local machine, fully connected to Azure artifacts, having functions trigger an item, and then being able to walk through my code to know exactly what's going on is a lot different to when I used to write alerts everywhere to kind of work out what's happening. But you also saw the outer loop. So Azure Functions are just like any other artifact that we create. We can have application insights to do our reporting and tracking and find out what's happening. We can publish them, whether that's through a simple process, straight through Visual Studio up into a development instance, or we can use full-on continuous integration and build pipelines to have a very managed approach for our artifacts if we need that for production and other scenarios. So we've talked a lot about Azure Functions now. Let's dig in a little bit into Logic Apps. But Logic Apps are where we're actually talking now about providing a little bit more structure, not these single event-fired functions. Logic Apps are still event-fired, but they're actually providing a workflow capability where we step through the different pieces and connect them in between. There's a heap of different connectors that we'll have a look in there. But they also have some similarities with functions in that their declarative definition of code behind it can actually be checked in or pushed into source control, and it can be deployed through an automated process as well. So even though I'll show you doing this through the Azure portal, you can have a managed deployment lifecycle on top. And the great thing about Logic Apps is they connect to pretty much almost everything. Even though we're talking about cloud-based technology here, we're not just talking about connectors to Microsoft systems. There's a whole heap of SaaS connectors through to numerous other applications, but we also have the ability to connect to on-premises and hybrid data sources as well. So you can actually use those bits and pieces and jump on-prem, push data into your systems, or use that from your Logic applications. Let's do a quick flick back to the demo. And we'll go across to Logic Apps. So what you can see here is a dashboard of a Logic app that I've already created. And it's actually a timer-based Logic app that kicks off every so often. And you can see here a lot of the runs that I've done of this previously. And it's quite extensive, you know, I'll go back with quite a lot of history. And with each one of these, I can actually click on them and it will give me a view of exactly what happened within each of the steps with my Logic app. Now, this is a pretty simple Logic app at this point in time. I'm kicking it off on a timer-based interval, and then I'm querying a document database to actually find out what those cat records are that we have in it at the moment. And then because I love email, I'm emailing the results to me. Really, really super simple. But you can see I can expand each of these and get quite detailed information, like what's in the body of the email? What are the headers? How am I connecting through to each of these bits and pieces? And really drill into a lot of detail. I can also use the metrics and alert rules to be notified when specific things happen as well. So for example, if a Logic app fails, I could trigger an SMS or I could trigger an email to an administrator to go in and remediate these kind of activities, which is where I would use my alert rules. And I can also see, so we'll just go in and we'll actually have a look at the editing of this function. So I go in there, and this is my Logic app. Now, this one is really simple at this particular point in time, but I just wanted to highlight some of the changes that we can do to add a bit more complexity. So with a lot of our items here, we can actually configure an item called configure run after. So this is a really interesting property where I can say only do this step, in this particular case, makes sense, only send that email if the step before is successful. Or you could only send it, you know, if it's failed or timed out, and that's how you can provide a little bit of basic logic around which of these steps to do in which particular use cases. But often you need to get a lot more complex. So you can see here I can add a direct action or I can add conditions, and that will give me a simple conditional. If this, do this particular action. If no, do whatever actions I put in here. But in addition to all those things, I can actually even do switch statements, for eaches, add do-untils, and get quite complicated with the logic that I'm actually going to put into this particular application. I can be really, really specific about how that flows through. And just like with the simple example you've seen here, for each one of those runs, you'll get those visual indicators of which path it went down, what the results were on each level, so you can actually get a really good picture of what's going on. And then I can add actions to connect through to a bunch of these other systems. And there really are a heap of things in here. I've learned a bunch of services I had no idea existed. It's, you know, almost endless scaling through here for connecting through. And you can see a lot of the things that you can do are, you know, for example, reading a file. Very, very common that you might have a Logic application that reads a file when it's put in a specific place, do some processing on that data, split it off into a few different things, and then put it into your enterprise business systems. Really good and easy. And with each of these, you also have a versioning capability. So as I'm making these changes, it is actually storing versions of each of these Logic apps, and I can actually go in through the UI and revert to a previous version of that if I found out I've made a big mistake. Finally, to get started, we also have a lot of templates, and this is a really good place to look and get familiar with Logic apps by just picking some of the out-of-the-box templates, and it will give you a guide as how they usually set up. And you'll see that these are some really easy ones, like when a message is received, do something. but also some really advanced business scenarios like, an X12 EDI document over an AS2. That's a pretty complex scenario there with hybrid integration that's being set up. So have a look at those templates, and they'll certainly help you get started. All right, so you've seen some logic apps, and you've seen how you can use that to kind of orchestrate a whole bunch of logic together and connect together into a flow those different systems. Remember, with logic apps, you don't have to use it with Azure Functions. All those connectors to business systems can be used completely independently, but you can use logic apps as those different steps in there, those functions as steps in there as well. Hopefully I've shown you that Azure has a comprehensive serverless platform, and it's something you want to go in and have a look at. So there's just a couple of links up here for how to get started. If you go to the Try Functions URL that's listed there, it gives you a nice little URL to get started with your first function and a little bit of easy way to do it. And then if you look at the GitHub link, it'll give you some more advanced scenarios of different bits and pieces. So I hope I've got you excited in our serverless platform, and you'll jump in and have a play.